Topic is random variables. Okay. Random variable definition. Here, a random variable X on a sample space S is a function from S into the set R of real numbers, such that the pre-image of every element of R is an event of S. Here we know that S is a sample space. It contains all possible ways of an event. Okay, S is a sample space. X is a random variable. Actually, it is a function from the sample space to the real numbers R. Okay, pre-image of every element of R is an event of S. Okay, therefore X maps every event of S to a real number. X maps every event of sample space to a real number. Now, what is discrete random variable? A random variable which can take on only a finite numbers is called a discrete random variable. Okay. Example is, for example, let us consider two coins. In tossing a coin 2 times or 2 coins, any one, we know that the sample space consists of these outputs, these outcomes. Okay, HH or HT or TH or TT. Here H means head, T means tail. Okay, what are the possible ways? Maybe they both are head, or one is head, one is tail, or one is tail, another one is head, or both are tails. Therefore, these are all possible ways for getting an outcome in tossing a coin 2 times, or in tossing a coin 2 times, or 2 coins at a time. Okay, let X be the random variable that assigns to each element of S the number of heads. Therefore, X is the number of heads. The number of heads in an outcome. Okay, X is the number of heads in an outcome. Okay. Already we discussed about X. X is a mapping between a sample space and real numbers. Okay, it always maps every event of S to a real number. Okay, what are the events of sample space? These are the events of sample space. First event is HH, second event is HT, third is TH, fourth event is TT. Okay, now since X is the number of heads in an outcome, in the first outcome of S, what is the first outcome? HH. There are 2 heads in the outcome. In this outcome, there are 2 heads. Therefore, X of HH is 2, and X of HT. X of HT means the number of heads in this outcome. Okay, because X is defined as it assigns. X assigns to each element of S the number of heads. The number of heads in an outcome. Therefore, since in this outcome HT there are 2 heads, we have X of HT is equal to 1. In the third outcome TH there are 1 single head. Therefore, X of TH is equal to 1. X of TT is equal to 0 because there are no heads in this outcome. X of TT is equal to 0. Okay. Now we can show this information in a table. Okay, this is tabular form. Capital X is random variable p of x. P of x is the probability of x. Okay, the probability of x. Okay, now capital X is, what are the possible ways? There are 0 heads, 1 head, 2 heads. Okay, okay, we know that the probability of getting 2 heads is 1 by 4, because there are possible ways, and for getting this one, 1 by 4 is the probability for getting this output. Similarly, for getting this output HD, the probability is 1 by 4. For getting TH, the probability is 1 by 4. For getting TT, the probability is 1 by 4. Therefore, for getting 0 heads, the probability is 1 by 4. Because for getting 0 heads means for getting TT, probability for getting TT is 1 by 4. Similarly, for getting 1 head is 1 by 4. There are 2 outcomes. For getting 1 head means HD or TH. Okay, what is the probability? Number of possible cases by number of exhaustive cases, or number of elements in sample space. Number of possible cases for getting 1 head or 2 cases, they are HD, TH. 2 by number of elements in the sample space. Number of elements in the sample space are 4. Therefore 2 by 4. 2 by 4 means 1 by 2. Now the probability for getting 2 heads. 2 heads mean HH. Okay, HH. This is the only way for getting 2 heads. Therefore 1 by number of possible cases. Number of elements of sample space 4. 1 by 4. Okay, that is about discrete random variable. Now let us know about continuous random variable. What is continuous random variable? Discrete random variable is defined as a random variable which can take on only a finite number is called a discrete random variable. Because here we notice that in this table 0, 1, 2 are finite numbers. There are only 3 cases: 0 case, 1 case, 2 case. Okay, for these 3 cases we have to find out the probability, and the probability for getting 0 heads, that is probability for getting TT, and the probability for getting 1 head, that is the probability for getting HD or TH, and the probability for getting 2 heads, that is the probability for getting HH. Okay, these are the only finite cases: 0, 1, 2. Okay, therefore for the finite number of elements we have to find out the probability. But in case of continuous random variable, a random variable capital X is said to be continuous if it can take all possible values in an interval. And actually in this case we have to choose an interval, and in that interval we know that there are so many points. For each point we have to find out for an interval we will find the probability. For a particular interval, an interval is given. For the particular interval you have to find out probability. The difference between discrete random variable and continuous random variable is, for a particular point we have to find out the probability. Okay, but in the continuous random variable we have to find out the probability in given interval. Okay, now what is probability density function? Consider the small interval x plus lambda x of length lambda x around the point x. let f of x be continuous function of x, so that f of x lambda x represent the probability that capital X falls in the interval x plus lambda x. Now the probability density function fx of x, that is the probability at x of the random variable capital X, is defined as fx of x is equal to limit lambda x tends to 0 probability when x is less than or equal to capital X is less than or equal to x plus lambda x okay. Therefore the probability for a variate value for a given value to fall in the finite interval a comma b is given by probability of a less than or equal to capital X is less than or equal to the probability for this interval which lies in between a and b is given by integral with the limits a to b f of x dx. Okay, that is, here f is probability density function. Okay. It is a map. In this map, interval is a to b. We have to find out the probability in between a and b. Okay, a and b. This is the curve f of x. Okay, f of x delta x is the required probability. Okay, to find the probability, to find the probability between a and b, it is enough to find out the area of this region. Okay, it can be found by this formula, integral with the limits a to b f of x dx. Okay. Therefore this is the area in between the curve y is equal to f of x, y is equal to f of x, y is equal to f of x, and x is equal to a line, and x is equal to b line, and x-axis. Okay, we have to find out this area. This area becomes our required probability in the interval a comma b.